So now that we have our area of interest, which in this case is this variable country for the country of Colombia, we're going to create an image composite utilizing Landsat 8 collection. So I'm going to just separate this part from the top. And for those of you who are very new to Google Earth Engine and JavaScript coding, these two forward slashes represent what we call a comment. So if you run the script, these two lines are not taken into account. So the code just skips over these two lines and runs the rest of the content. And we're going to start with Landsat 8, just because it's the most recent satellite from USGS. And we're going to use the surface reflectance product. So if you want to take a look at this data set, you can type here in the search bar, Landsat 8 surface reflectance. And we're going to use tier 1, which has a higher quality than tier 2. There's an explanation on tutorial about the differences about these two products. And you can see same thing, you have descriptions, you have which bands that the images have, and image properties, which are the metadata. So again, we're going to copy this collection snippet, which is the dataset ID. And we are going to create a variable here, which I'm going to call L8. Then I'm going to paste that ID. I want to note that if you try to print this collection, it's going to throw an error. And that's because we are trying to print the entire collection of Landsat images in the entire globe since its first image acquisition. So you can see that the error here shows that it accumulated over 5,000 elements. So it's too much data to handle. That's why it throws an error. So we can delete this. And what we need to do, because we're creating an image composite for the year 2019 in the country of Colombia, we need to filter this collection just to have images for that study period in that study area. So I'm going to create a new variable called L8 filter, just meaning that it's filtered, and then it's going to equal my L8 variable. We're going to use the filter bounds function in GE, which is made to filter images according to the bounds you provide. In this case, we're going to use our country variable, which is our study area, and we're going to filter by a date. So we're going to create an image composite for the year of 2019. And for the filter date function, we need to provide two dates, a start date and an end date to filter images within that period. So because it's 2019, we're going to have 2019-0101, so filter images from January 1st, 2019. And in Google Earth Engine, the default date format is year, month, and then date. And then our end date is going to be 2019-12-31st. So we're going to filter every image that is in between January 1st, 2019 and December 31st, 2019. So now if you actually try to print this collection, L8 filter, then you do not run into an error, because if you see here in the console, you have an image collection which has 956 elements. And you can open here the features where you can see all of the images that this collection has. So I'm going to push this back to the side. And you may have noticed that it took a while to print this collection and also to add our layer country to the map. And that's because we are working on a national scale. So one way to deal with that is to comment out lines of code that we're not going to use. So we do not want our country layer to be added to the map every time we run the code. So let's go ahead and comment out this line. And you can do that by adding those two forward slashes, or you can also press Control// on your keyboard, and that gets added automatically. So I'm going to do this for this line and also for the line where we are printing our collection. You should only print collections or images or feature collections that you're actually going to consult here on the console. So I'm also going to go ahead and click on the line and then press Control// to comment out this line. So now we can create our variable composite, and we're going to have a median composite, meaning that what Google Earth Engine is going to do is he's going to reduce the image collection that we have. And by reducing, what I mean is that it's going to calculate the median value per pixel over time. So we can go ahead and create a variable here, which I'm going to call composite, and that's going to be our filtered image collection using the median function. So now if I try to add this layer to the map, you can see that an image is going to be added over Colombia. And when it loads, you're going to notice that the image is going to be all over the country. It doesn't have, defined boundaries. So we need to add the clip function so that we have an image that overlaps with the boundary of the country. So to do that, we're going to add here clip, and then we're going to use our country layer that we defined as our study area, and then run. So now the composite got added to the map and it has the correct boundaries, but you can notice that the color is this grayish. And that's because we have not defined any visualization parameters for the image. If you remember, I mentioned about these two curly brackets here, and that's where we define our visualization parameters. But for now, what we're going to do, we're going to just going to inspect this layer here. You can see that it has this gear icon. If you click on it, it's going to show the visualization parameters. So right now it's set to be an RGB composite, and it's using bands 1, 2, and 3, which in this case for Landsat 8, these are the ultra blue band, the blue band and the green band. We don't want that. Let's try to do a red, green, blue composite. So we do band 4, band 3, and band 2. And then here the range, these are the pixel values. Usually what I do is I just select one standard deviation to see how it looks. Once you click here and select your range, your stretch, these values get automatically populated. So you can see that the values here changed, and then you can click apply to see the results in the map. And you can close this window to see the results. Again, it takes a while to load because this is a computation on a national scale. And that's also why you see the script error here in the console, but do not worry about that, as you see the composite is loaded into the map. And if you like these visualization parameters, one thing you can do is to import them. You just need to click in the import button, and then here in your import tab at the very top of the script, you can see that there's a new variable called image_vis_param, and that's what we use here in the curly brackets, but in this case we're going to do for our composite. So if you want, you can define here image_vis_param, and then we can also name this layer. We can call L8 composite 2019. So now if you run this, the layer gets added to the map with those visualization parameters. I'm not going to use this visualization parameter, so I'm going to delete this import. And I'm going to just show how to define your visualization parameters using the curly brackets. The first thing is defining the bands, which you're going to keep the RGB composite. So it's going to be B4, B3, and B2, so red, green, and blue. And then here we define values, which I'm going to define from 300 to 3000. And as a reminder, these are surface reflectance values. But this composite doesn't look good. We can see that there is a lot of clouds here. So what we can do is filter this collection also by cloud cover. So I'm just gonna add another filter function here, which is gonna be called filter metadata. We used this before when filtering our international boundary dataset. And this Landsat A surface reflectance product, it has a cloud cover metadata where we can filter by cloud cover percentage. So we're gonna use that cloud cover, and I'm just gonna have images that contain less than 50% cloud cover. So now, because I changed in my filtered collection, if I run this, we can see that the composite is going to look different, since now we're filtering images with cloud cover less than 50%. You can see that the composite looks a little better. It's still very cloudy here, but you can see that it's missing some data here because we are applying a filter. The collection might not have enough images in some of the regions. Like here on the left side, you can see there are some missing spots. I also want to note that if you try to print this image collection, it's definitely going to show less than 956 images because we are having less images since we're filtering some of them. And you can play with this threshold. You can try, for example, 20 and see how the composite looks. And you can see that the result contains even more gaps, and that's due obviously to the persistent cloud cover in the country of Colombia. And to mitigate this, we can apply a cloud mask. Luckily, Landsat 8 collections contains a quality assessment band. It's the QA band, and that provides useful information with certain conditions within the data, which allows the users to apply some per pixel filters. And for that, we're going to create a function to apply the cloud mask to each image in our image collection. But before creating the function, I just want to show here in the bands of the Landsat 8 collection that you can see down here the pixel quality assessment band that I mentioned. You can find links on the tutorial that will provide information about the pixel QA band. So for a cloud mask function, I'm just going to go straight into the Google Earth Engine page about the Landsat 8 surface reflectance data. You can just use Google to find this page. And you can see here, the first one that comes up, it's an explanation about the collection. And down here, they have, the same description, bands, and image properties that we can also retrieve from the search bar in Google Earth Engine. In here, you can see that they provide a function to mask clouds. So I'm gonna copy and paste this function because this is exactly what we need. And I'm going to go back to our code and paste the function right here. So how the function works is to first define the name of the function, which in this case is mask LASR, so mask Landsat 8 surface reflectance. Then the argument that it takes, in this case it's image, because we want to apply this function to every image within the collection. Then the middle part are all the statements that the function is going to perform. And finally, you define what you are returning, which is our image with the cloud mask applied. So the quality assessment then contains bit information, and of particular interest here, bits 3 and 5, which are cloud shadow and cloud respectively, and we want to mask both of them. So here we are defining each bit mask, and we are using the left shift operator to shift the first operand 3 bits in the case of cloud shadow and 5 bits in the case of cloud. Then we are defining this variable called QA, which is simply our quality assessment band QA. And in Google Earth Engine, the select function is used when you want to grab just a specific bands of the image. And then finally, we do not want pixels that show these bits 3 and 5. So we want them to be 0, and that's why we have our bitwise AND operator here for each of the bit masks equal to 0, and then we return our mask image by using the update mask function. So now if we want to apply this function to our collection, what we can do is go up here in our collection and we can add the map function. So the map function is going to map that specific function through all images in the collection. So we do map and then we add the name of the function, which in this case is mask L8SR, and then we can click run. I'm gonna change this to 60 just because 20 had many gaps, and now I can click run. I'm actually going to adjust these parameters here, minimum and maximum, because it's really dark. So I'm gonna use 0 and 2000. Now let's check by clicking run. And to check how much of an improvement it is, what I'm gonna do is create another composite where we are not masking the clouds. So here I'm gonna call this collection 2, L8 Fut 2, and then I'm gonna exclude this last line where I'm not applying the function. And then I'm gonna copy these 2 lines of code where I'm gonna modify here to composite 2, map add layer composite 2, and we are going to use our unmasked collection L8 Fut 2, and then here I'm going to change this to unmasked. Press run. So now you can go to the map. You can zoom in a little bit to see the better result from the masked layer. So at the top we're seeing the unmasked one, and the one in the bottom is the one with the function applied, and you can see that it's a lot of improvement. We still have a lot of gaps for National Composite, so in the next video we're going to learn how to add one more year of data.